Welcome back to D Machine. This is the place where we explore the machines, the factories, and the heavy-duty engineering that quietly keep our world moving. Today we're stepping inside one of the most important yet overlooked parts of modern transportation, the manufacturing of trailer rear axles. From raw steel to heat, pressure, precision machining, welding, painting, and final assembly, every axle carries the story of craftsmanship and industrial discipline. And in this video, we'll follow that story step by step, watching how ordinary steel transforms into the durable backbone of freight trailers worldwide. Now, let's begin the journey. To begin the manufacturing of a trailer axle, everything starts with these heavy bundles of seamless steel tubes. Each tube is selected for its strength, uniform thickness, and ability to withstand extreme loads on the highway. From the storage yard, the raw steel is moved into the heating line, where a medium-frequency induction furnace brings the metal to a glowing orange state. At this temperature, the steel becomes soft enough for the later forming of the axle spindles, the most critical parts where the bearings and hubs will mount. As the tube rotates, the furnace precisely controls heat penetration, ensuring even temperature across the entire circumference. This consistency is vital, because any uneven heating could cause internal stress or dimensional distortion in the final axle. Next comes rough forming. While the steel is still blazing hot, machines compress and shape the softened tube, preparing it for precision machining later. Every step here must meet strict tolerances, usually within plus or minus 0.1 millimeter for diameter, roundness, and straightness. Only after passing these early checks can the glowing tubes be lifted and transferred to the next station. This marks the completion of the first stage in building a heavy-duty trailer axle. Once the heated tubes cool to a workable temperature, the next stage begins, forming the axle beam. Each round tube is clamped into a powerful pressing machine, where multiple sets of rollers and dies gradually force the steel into its new shape. The operator checks every section of the tube, ensuring proper lubrication and alignment before the machine starts its stroke. With every pass, hydraulic rams apply immense pressure, squeezing the once round tube into a more controlled profile. This progressive deformation is carefully engineered. Too much pressure will crack the steel, too little won't achieve the required strength. As the tube moves through the forming dies, its cross-section slowly transitions from round to a more rectangular or square profile. This shape is essential because a square axle beam resists bending far better under the heavy loads of a semi-trailer. The ends of the beam are also preformed into tapered sections, where the spindles will later be welded. After the axle beam has been fully formed, it enters one of the most critical stages of its construction: heat treatment. To meet the strength requirements of modern trailers, the entire beam must be hardened and tempered with absolute precision. The axle is first pushed into a high-temperature furnace, where the steel is heated to around 860 degrees Celsius, a temperature carefully maintained by automated control panels. At this stage, the internal structure of the metal transforms, gaining the potential for high hardness and durability. Once the beam reaches full temperature, it is transferred rapidly to the quenching station. Here, a powerful shower of cooling fluid crashes onto the glowing steel, locking in hardness and significantly improving its wear resistance. This sudden thermal shock must be precisely timed. Too fast and the steel may crack, too slow and it won't reach the required strength. After quenching, the axle undergoes a second heating process called tempering. This step reduces brittleness while restoring toughness and elasticity, ensuring the axle can withstand millions of miles of vibration, twisting, and heavy loading on the road. By the end of this heat treat cycle, the once simple steel tube has transformed into a high-strength structural component, ready for machining and final assembly. After heat treatment, the axle beam is strong, but its surface is covered with scale, oxidation, and residue from the furnace. Before any machining or welding can begin, the entire beam must be thoroughly cleaned. The axle enters an automatic shot blasting machine, where thousands of steel pellets strike the surface at high speed. This process removes rust, oxide layers, oil stains, and any impurities left from earlier steps. Shot blasting not only cleans the steel, it also creates a uniform surface roughness, ideal for paint adhesion and long-term corrosion resistance. Once cleaned, the axle beam moves directly to the coating line. Inside a sealed chamber, spray nozzles apply a protective industrial coating, covering the entire body of the beam. This layer prevents rust during storage, transport, and later during service on the road. The coating must be even and consistent, ensuring no weak spots along the axle's length. Freshly painted beams are then placed on racks to dry, revealing a smooth, durable finish. With its surface fully protected, the axle is now ready for precision machining and assembly, the next big steps in transforming steel into a working trailer axle. Once the axle beam has been cleaned and coated, it enters the most precise stage of manufacturing, machining. Here, the rough axle is transformed into a fully finished, dimension-accurate component. The beam is first mounted onto a heavy-duty lathe. Through a sequence of rough turning and finish turning, the spindle ends are shaped to exact diameters and tolerances. Coolant flows continuously to prevent overheating and to protect both the cutting tools and the tempered steel beneath. Next, machining centers drill and bore the internal cavity at the end of the spindle. This hole will later accommodate grease flow, end caps, or locking pins, depending on the axle design. The drilling accuracy here is crucial. Even a small deviation can affect wheel alignment and bearing life. After drilling, threading tools cut precise external threads onto the spindle. These threads will hold the hub nut and secure the wheel assembly in place. The cut must be perfectly smooth, with clean thread profiles and no burrs, ensuring safe locking under heavy highway loads. By the end of this stage, the axle's spindle sections are bright, polished, and fully machined, ready for welding the flanges and assembling the final axle. With the spindle ends fully machined, the axle moves into the welding and assembly line. This stage adds the critical components that allow the trailer's brake system and suspension to function reliably. Skilled welders position each brake bracket precisely along the beam, aligning them according to strict jig fixtures. A small error here would affect brake alignment, wheel tracking, and even tire wear. Once everything is set, high-temperature arc welding fuses the heavy cast brackets to the axle body, forming a permanent structural joint. Every weld bead must be consistent, smooth, and free of defects. With the brake brackets securely welded, the axle moves to the camshaft assembly line, a stage that brings the braking system to life. Technicians begin by inserting the long brake camshaft through the welded bracket housing. This shaft is what transfers motion from the air brake chamber to the brake shoes inside the drum. A precise fit is essential. Any looseness would cause delayed braking, and any tightness would create premature wear. Once inserted, a series of bushings, seals, and locking rings are installed to ensure the camshaft rotates smoothly under heavy loads. Every component is greased carefully to prevent corrosion and to maintain years of reliable service on the highway. Next, the workers align the slack adjusters and attach them to the shaft ends. These mechanisms automatically maintain correct brake clearance, a critical safety function for large trailers. By the time the axle reaches the end of this station, each beam is equipped with perfectly centered, fully functional brake cam assemblies. In the final stage, the fully assembled axle enters the automatic finishing line. Each unit is cleaned once more before receiving a protective industrial coating. Inside the spray booth, robotic nozzles apply a uniform layer of paint that shields the axle from rust, road debris, and harsh weather. The coated axles then move into a curing chamber, where heat ensures a strong, durable finish. When they emerge, the axles are fully protected and ready for installation on heavy-duty trailers. In the final assembly stage, each axle receives its brake components. Workers begin by preparing the large brake shoes, pressing bushings and rollers into place with careful precision. These parts must move smoothly to ensure balanced braking under heavy loads. Next, technicians mount the brake shoes onto the axle, connecting them to the camshaft installed earlier. Springs, pins, and adjusters are fitted one by one, forming a complete brake mechanism. Once assembled, the entire unit is inspected for alignment and smooth operation. Rows of finished axles roll off the line, fully equipped, tested, and ready to be installed on modern trailers. In this stage, the focus turns to assembling the trailer's brake drums, the heavy cast iron components that convert braking force into stopping power. Stacks of freshly machined drums are delivered to the line, each one checked for roundness and surface finish. Technicians begin by fitting the bearings into the drum housing, adding grease to ensure smooth rotation under high heat and heavy loads. The drum is then positioned into an automated press where bolts and mounting hardware are tightened to precise torque settings. Every step here must be exact. Even a small misalignment can cause vibration or uneven braking on the road. Once fully assembled, the drums undergo a final inspection before being staged for installation onto the axle. These rugged components complete the braking system and prepare the axle for its final journey to the trailer assembly plant. In the final stage, the nearly completed axle assemblies enter the hub installation and lubrication area. A technician applies a thick layer of deep blue specialized grease across the spindle surface and splines. This protective coating reduces friction, prevents wear, and ensures the hub can operate reliably for many years, even under heavy loads or extreme temperatures. Next, the fully inspected hub, checked for concentricity and proper bearing clearance, is lifted into place and pressed precisely onto the spindle. Every component, from the bearings and oil seals to the inner races, is aligned according to factory standards. The technician then tightens all mounting bolts with uniform torque, eliminating vibration during operation. Once the hub is secured, safety locks and cap covers are installed. The technician wipes away excess grease and performs a final inspection on every connection point. The finished axles are then moved to the protective wrapping area. A thick layer of PE film is wound around the hub and axle body, guarding against moisture and scratches during transport. Finally, a forklift loads the bundled axles into shipping containers, stacking them in layers to maximize space and ensure safe export. From raw steel billets to precision machining, welding, coating, and final assembly, each trailer axle is now ready to leave the factory and support the logistics industry across the world. Every axle you've seen today represents more than steel and machinery. It represents the unseen work that keeps goods moving, keeps industry supplied, and keeps our modern world connected. From raw metal to a finished axle ready for the open road, this is craftsmanship on an industrial scale. If you enjoy exploring machines, factories, and the engineering behind everyday life, don't forget to like, subscribe, and share. Thank you for watching D Machine, where industrial stories come alive.